Welcome back to part 2 for simplifying roots. We've already seen most of the things we'll do with roots this year, but this will go through a couple more things that we will use them for. So first things first, rules for simplifying roots. First thing you want to do is remove any perfect squares from a radical, and we just talked about that. That was the last video. So if you're still kind of shaky on that, go back and watch that one again, but any perfect square multiples inside of a square root should be removed if you can, and then that's all we did in that last video. These last two we're going to focus on now. So you should never have a fraction inside of a radical. We won't see that too much, so we're mostly going to focus on 3 here. There should never be a radical in the denominator of a fraction. So when we see that, we're going to learn right now how to handle it. So for example, on the next slide here, there's 2 fractions, both with some kind of root in the bottom. This is a square root, this is a third root, but we don't like that. There's a few reasons why, mainly that it's not easy to simplify it, and sometimes you can get a better answer if you don't have a square root or a third root in the bottom. So the trick here comes down to properties of roots, and basically what we're trying to do is take this square root of 3 and make it whole. Turn it into a solid number. And what you have to remember is the square root of 3 is what number multiplied by itself would turn into 3. It's some decimal, it's like 1.7 or something like that. But you're asking yourself what times itself gets you to 3. So technically, if you multiply this by another square root of 3, that would be the value that would turn back to normal 3. And again, picture our properties of exponents here. This is technically 3 to the 1/2. If you multiply it by another 3 to the 1/2, you could add those two powers together. A couple halves added up is 3 to the 1st. So if you do this, it'll turn the square root of 3 into a regular 3 on the bottom. Now, you can't just randomly do whatever you want to the bottom of a fraction without breaking the whole thing. So this 5 has to have something happen to it as well. You have to multiply by both top and bottom the same value. Okay? And the reason this is okay, picture what square root of 3 divided by square root of 3 equals. That's technically just 1. So all we've done is we've taken this original fraction, we've multiplied it by a fancy version of 1. It still equals the same decimal approximation, it still equals the same value, but now it's going to look different. It's going to be a little more useful for certain things throughout the year. Okay, so on the bottom it became normal 3, on the top 5 times the square root of 3, we can't do anything with that, but we at least accomplished fixing the bottom. And this is where you leave it, you can't do anything else there. If the 5 and the 3 are reducible, we'll do that. We'll see that in the next problem, but for now that's all we can do. Okay. In problem 2 here, we've got a third root. Now, picture what we saw here. A square root times another square root. The half powers combined. We made a solid 3 there. We were all done with that. The question is, if I have a third root of 2, how many more third roots of 2 do I need before this becomes a solid number? And it comes down to the same property here. A third root is technically a 1/3 power. So if I continue to multiply by additional 2 to the 1/3, I'm going to need 3 of them before I actually make a solid 1 with all these 1/3 added together. So you could do that a little bit shorter if you want. Since I'm multiplying by another 2 of these, an extra 2 of them, you could do, well, third root of 2 squared is both of these combined. Or you could just write it twice, doesn't matter, but you need an extra 2 of these to make a solid pair of 3. And picture again, we saw when you're trying to break down roots, if you have a third root, you need 3 of an item. If you have a square root, you need 2 of an item. So I'm giving myself 3 of them by using that property. And again, I have to balance this by doing it to the top, so I will do that as well. And in the next line, I'll make this a 4. You don't need to write it as 2 squared forever, so I will make that a 4. Next line will be 6 times this. Again, you can't really do a whole lot with that. You usually won't be able to do much with the top. It's really just your focus on the bottom. You're trying to get whatever you can have happen here to fix that. And now this is a solid 2 like we wanted. Again, look at the final result. We might be finished, we might not. Turns out we can reduce the 6 and the 2, and this final answer, I'll put it down here, would be a normal 3, and then the third root of 4 is still here. Alright, and this is the main point of doing all of this work, is oftentimes we're going to get to the point where there's no fraction anymore. And usually that's a very good thing. Fractions get pretty messy when you're getting into complicated problems, so if you can get rid of a fraction, it's pretty nice. So this would be your final answer for this guy. The last thing we'll look at is something like this. This is about as weird and annoying as it gets. You might think, well, we've got a square root of 2 in the bottom, and we've got to fix that. We just saw previously as well, if I just multiply by square root of 2, that should fix everything, right? Because the square root of 2 times itself will turn back to normal 2, that's great. The problem here is this extra 1 plus. That ruins everything, because if I try to do this, the top will be 3 square root of 2. That's not bad. I mean, we knew something would happen to the top. But in the bottom, what's going to happen is 1 times the square root of 2 would be square root of 2. Square root of 2 times 2 would become regular 2. But because you had to distribute this square root of 2 to both things, it didn't actually help us. The 2 is good, but now the 1 became a square root of 2. It's still got the same issue. So this wasn't wrong, it's just not going to help us. So let's erase that and we'll start over here. Okay. Here's the trick. When we get into our factoring videos, I'll talk about this a little bit more, but the idea is that if you have x plus y and you multiply it by x minus y, you just use the FOIL method or the distributive property, whatever you want to call it, and you distribute this out. X times negative y, you get x squared minus xy. Go with the other direction as well, y times x, y times negative y, you get a plus xy and a minus y squared. The trick about this that I'm trying to show is that in the middle here, we have a negative xy and a positive xy. That will go away, and we'll just have these two squared values at the end. And you could factor this back to the two groups up here. This is one of the most commonly used factoring methods. Is you'll see a lot of times where it's squared minus something else. But we're going to use this idea on this problem. So notice how we got the middles to go away. That's the whole goal here. So if I multiply 1 plus square root of 2 by its opposite here in the middle with a negative, I'm going to get something to disappear. And it turns out I'm going to get the square root stuff to disappear in this situation. So let's try that. This is 1 plus square root of 2. Let's try multiplying this by top and bottom, 1 minus the square root of 2. You could actually do the square root of 2 minus 1. Also, it'll accomplish the same thing, but let's just change this symbol only. We don't need to make anything more complicated than necessary. The top, we will have to distribute the 3 to both of those. So the top is going to become 3 minus 3 square roots of 2. And again, we knew the top would get kind of messy, but that's okay. We're focused on the bottom. As long as we fix that, we'll be okay. We do have to completely FOIL the bottom, kind of like what we did over here. So let's do 1 times 1. That's a solid 1. 1 times the negative square root of 2 would be a minus square root of 2. Plus square root of 2 times 1 would be a plus square root of 2. The square root of 2's multiplied together, that would be a minus, and that does turn into a solid 2. That was kind of what we saw before. So, and again, here's the whole point. Look at our middle here. We have a negative square root of 2 and a positive square root of 2. That is now gone. So in the bottom, we now just have 1 minus 2, which is just negative 1. So 3 minus 3 roots of 2 divided by negative 1. Our final answer is going to be just to simplify that negative 1, y right divided by that. It's just going to change both signs here. So negative 3 will be in front. This minus will turn into a plus, and 3 root 2. And again, once we did this process, we no longer have a fraction. That won't happen every time, but it is often enough that it's useful to do this. We don't want to deal with fractions when we can. Okay. So just a quick recap. If you just have a normal square root, no matter where it is, your goal is to take out any perfect squares, any factors that can be taken out. If we had a fraction, let's just go and do this real quick because it's the same idea. Let's say you had square root of 2/3. Use the exponent properties, and you can say, well, 1/2 power on 2/3. If we raise that to the 1/2, that's technically 2 to the 1/2 over 3 to the 1/2. So we can apply the power to both things. Square root of 2 over square root of 3. We now have a square root on the bottom. Do the stuff we just did. Okay, so that's why there should never be a fraction inside a square root, is because it's technically the same as this, and we'll fix it that way. Okay, so then the other thing is we just said if there's a square root in the bottom, fix it. If it's a simple square root like these, you just multiply by an extra copy of yourself. That'll accomplish what you want. If it's got a plus or a minus, it gets into this sort of stuff. You've got to just make it opposite and go from there.